Right, matrix transformation and a bit of matrix proof here. So we've got a matrix and we're given some information. So the point with coordinates 1, 1 is mapped onto the point with coordinates 1, 3. So we take our matrix and I want to know where 1, 1 goes, and I know that the answer is 1, 3. And that's how we do our matrix transformations. You pre-multiply the vector by the matrix. Now I can actually do the multiplication on the left hand side. So remember, this is going to be first row, first column. So that would give me 2 plus A. And then for the second element, it's second row, first column, 3 plus B equals 1, 3. And then I can split this up into the 2 rows. So the x coordinate 2 plus A equals 1. Y coordinate 3 plus B equals 3. So that gives me that A is -1 and B is 0. Okay, now I've got to do a bit of a show that A squared is the same as 2A subtract 3 times I. Right, first of all, let's work out what A squared is. So now know what my matrix A is. My matrix A is 2. A was -1, 3, B was 0. So A squared is the matrix times itself. Okay, so we've now got 4 elements going on. So first row, first column gives me the element in the first row, first column. So 2 times 2 plus 1, -1 times 3. Then we go first row, second column, the element in the first row, second column. So 2 times -1, -1 times 0. Okay, so second row, first column. And finally, second row, second column. Let's kind of cover up my numbers now. So that's going to be 3 times -1 and then the 0. So simplify all that, I get 1, -2, 6, -3, which is A squared. Right, I've got to show that's equal to 2A subtract 3I. It's probably easiest in this case just to work out what 2A subtract 3 times I is. So that's 2 lots of A, subtract 3 lots. Remember, I means the identity matrix. We're doing a show that, so it's worth showing a bit of working. So that's going to be 4, -2, 6, 0. Subtract 3, 0, 0, 3. And remember, when we do subtraction, we're just going to subtract the corresponding elements. So that's going to be 4 take away 3, -2 take away 0, 6 take away 0, and 0 take away -3. As you can see, those two things are the same. So A squared is 2A subtract 3I as required. Okay, now we've shown that, they are also giving us some information. So the inverse is A to -1, and I was the identity. Now they want us to use part B to show 2 more proofs going on here. So we're not going to need to work all these out. We can now use what we know about matrix multiplication to work these out. Move that so it's a bit smaller. Okay, so we're going to start with what we found in part B. And we're trying to get to A cubed. So what can we do? So we want to get to A cubed. Let's multiply by an A, but with matrix multiplication you have to keep the order the same. So if I put the A, oops, that's an A squared. If I do A squared times A, it's come after the A squared, so that's come after the matrices on the other side as well. So A squared times A is going to be A cubed. On this side, you can, with matrix multiplication, we can multiply it into the brackets as long as it's at the end of the brackets there. So that's 2a squared. Subtract. Now the identity times any matrix is itself. So subtract 3a. As you can see, we're not quite there yet. We've got a cubed, but we haven't quite got the other side. So if we have a look at this, I've got a squared. I didn't want an a squared in the answer, but up here I've got an expression for a squared. So a cubed is 2 lots of 2a subtract 3i. Subtract 3a. And if I simplify that, you can now see that I have got exactly what I was asked to prove. Okay, now I want to do an inverse, but we've got to start again with what we discovered in the first part. So that was 2a minus 3i. Right, I want to get to inverse matrix. So what it might be a good idea is to multiply both sides by the inverse of a. Okay, on this side I can split that a squared up into a times a, and then we're going to multiply this in. Right, whenever you've got an a times an inverse, that makes the identity matrix. So that side becomes just a times the identity, which is a. Here I've got a matrix times its inverse, so that also just becomes the identity matrix. And here I've got an identity times inverse, so that is just the inverse. So now I've got a equals 2 times the identity minus 3a to negative 1. Right, what were we trying to get to? We want to get to a to the negative 1. So a bit of rearranging here. So a plus 3a to negative 1 is 2i. The 3a inverse is 2i subtract a. So it's not really to negative 1, that's the inverse. And as you can see, all I've got to do now is divide by 3, which is the same as multiplying by a third. And then I've got the answer they were looking for.